This project is the start of a new tutorial series on PCG Interiors. So we're going to start out by building a room that we can easily change the size of and control where doors are. And then we'll be able to build off of this room onto more expansive projects later. I'm just starting from a new third-person project here and going to delete all this existing stuff on the level so we can start with a blank plate. Then we're just going to create a new folder called PCG that will keep everything that we're building in. And we're going to start out with a blueprint actor class, and that's just going to be BP_room. And then we'll also have a PCG. First, we need to go up to plugins, make sure we have procedural generation. Turn that on. That should be the only one we need for this. We will have to restart the project after doing that. Okay, now that we're back, we can create the PCG graph. We just want to create a PCG_room. Then we're going to go into our BP room. And then in this blueprint, we're just going to open the full editor and we'll add a PCG. Set that to be our PCG_room. So in our BP room, we're going to use this mostly to pass parameters into the PCG graph, but we'll also get a few things off the parameters passed in so we can pass those into the PCG as well. Start out by adding a few variables here. We want a wall mesh. Going to be a type static mesh object, floor mesh, and a door mesh. We're also going to set a room size. This will be the size that we want the room to be, and that will be a vector 2D. We'll make those all instance editable, so we can edit those when we bring this into the level. Then we're going to start out with our floor mesh. We're going to do a get bounding box. This will give us the size of the floor mesh. Split that. Subtract the minimum from the maximum, which will give us the size. Split that, and that's going to be our cell size. Do a branch here and make sure this value is valid. Otherwise, it's kind of useless. Recombine those, they shouldn't have been split. Promote that to a variable called cell size. And we'll make that visible as well so we can get it in the PCG graph. Compile and save. The room size, it's nice to set that as an XY, where X and Y are just the number of cells. We want to multiply our room size by our cell size, and we'll promote that to a variable called the extent, and we'll use that in the PCG graph instead of this room size. Set that, split it, multiply them together, and hook everything up. Now I just straightened out all the lines, and then we'll pop over to the PCG graph. We want to get actor property, and we are going to get the properties that we just set up, and we have to do that by name. So we need to get all these with the same name that we set up on the blueprint. And what I'm going to do here is I'm going to set up the out attribute name as the same thing, and then I'm also going to rename these so we can see when they're in the graph here which attribute they actually are. And we'll do the same for the room extent and the cell size. So I should put these down here in a different order. So I'm going to put the room extent up top here. We don't need this input right now. We're going to put the cell size right after that. We're going to do the floor mesh after that. Wall mesh and door mesh we're not going to deal with till later. And what we want to do first is we want to break vector, and we're going to divide it in half. That's the full size of the room, and we want to do the extent of our grid that we're going to lay the room out with from the center to the edge. If we divide this in half, we'll get the dimensions from the center. Get a constant, we do an add attribute, and then we just set the number. And then we're actually going to use this a lot. What I'm going to do here is I'm going to collapse this to subgraph, and we're going to go into our PCG. I'm going to make a new folder called PCG functions. We're going to have a few PCG functions. I'm just going to call this PCG half. Go into that and get it so that it's working right. We need to add the output here. Let's call out value. Set that as an attribute. And now we have a nice little PCG function here that we can use whenever we want to divide something in half. Oh, I don't like the name of that input. Let's change that too. So we're just going to duplicate this because we're going to do that for both the X and the Y. I'm going to remake that into a vector with make vector attribute. And then we're going to go ahead and create a points grid. So the create a points grid is going to give us a square grid of points that we can use to spawn things in with. And that's what we're going to use to spawn the floor tile and build the other things that we need in the room. But we're going to take this is our extents, the cell size off the cell size that we set up in the blueprint. And that'll create our point grid. Copy this here, paste it over. We're going to divide the cell size in half as well. And then we'll use an extents modifier. We're going to take these points and we're going to modify their extent with this out value. And we can call this floor extent. Now if we take our BP room, go back out here to the map, and we'll throw that BP room in here. We can set our meshes. We can just use a generic floor mesh for now. And then we're going to set our room size, let's say 10 by 10. And you can see it built the extent and the cell size, and then we can go back into our PCG room, get the floor extent. The create point grid, we want to uncheck the cull points outside of volume. By default that's on. We're not using a volume, so you want to turn that off. Inspect that with A. We have the points coming out. We have the points coming out of the floor extent, and they have the bounds min, bounds max set correctly. If we look at this floor extent, we can see that the steepness is 0.5. That's going to cause issues later if we leave it. So let's reset that. We'll use point match and set. We can use that to set an attribute, and we'll set steepness. We want to set that to 1. So we just set that value here to 1. And then we can rename this to set steepness 1. So next, these points that are created here are created at 0, 0, 0. So we want to move those over to our room location. We'll use copy points to do that. Source point is the grid points, the location. We create points, and then we create a point local at a single position 0, 0, 0. That will be the actual location of this blueprint. And we just need to hit points to create, and let's add a point here, and that point, this default data is fine. So inspect that node, and we can see we have a point created, and the position is the position of our blueprint. So then we just connect that up to our copy points as our target, debug that, and we can see we have a big white grid here. And what that is that's all our points being created by our points grid and set to the size of our floor. So that's ready to spawn our floors in. We want to add attribute, and the attribute we want to add is just called mesh. And we're going to take our floor mesh, drag that over here so we don't have to run a long line right now. And we'll connect that up, and then we're gonna static mesh spawner, and we will turn this debug off. So then our static mesh spawner, we need to set to PCG mesh selected by attribute, and that attribute we want is this one right here. Attribute name is mesh. Save that, and you should see our floors all spawned in at the size of our room. What we want to do next is create the walls. And to do that, we want to create a spline around the walls. We can create a spline from the corner points, and to find those corner points, we'll use our center position from this create point, and we'll use our room extent. So let's get those a little more accessible. We're going to take this room extent, we're going to split that vector again. Going to do an add here as well. What I'm going to do is just add the center point to it. And I'm going to grab these two, and we're going to collapse to subgraph. So we have a subgraph that we can work with here. This is going to be another function we're going to call PCG get corners. Rearrange our pins here. This will be our center, and this one, the second one here, is our room extent. So what we want to do is come from the center and add on half the X and half the Y in each direction. And since we're going to use half of the room, we can actually go back to our main graph here. We already divided that in half here. So if we take this one instead of the room extent, that will give us the half we need. So to create a spline from this, we want to put these points together in the correct order. We're going to go positive x, positive y, then we'll go positive x, negative y, negative x, negative y, negative x, positive y. So we're going to get our negative x and negative y here. To add attributes, we have a constant that's going to be -1, and just multiply that by our x. Oops, that's x. We want y up here. And we can change these labels to make this a little more clear. So for this first addition, this is our positive x, positive y. And then we're just going to duplicate this and label each of these appropriately for all the different additions we need. Connect all the A's up to the center. We'll just make a little room here. And then we'll use make vector to make all these back into vectors again before we add them. Connecting each make vector up to its appropriate add for plus x minus y, minus x minus y, and minus x plus y. So now we have the four corners. We're going to merge those. And return the corner points as a point value. And then this function is ready. So now we have our corner points. From our corner points, we want to create a spline, and then we'll sample that. Sample that by distance. And the distance we want to sample on is our cell size. We want to break that vector because we just need an x for our distance increment, and then we can shrink that down. We've got to go back into get corners. If we look at these right here, we want to add to the position. I forgot to set those to position. So all these get set to position. So I guess we have to set each of these individually. Now when we look at this spline, debug this spline here. You can see the spline is going around the outside of the shape now, which is good. You can see that the spline shape is incorrect. We want this to be linear and closed loop. So for this to work, we need to set on this break vector attributes, we need to set the output as distance increment. And then on this spline sampler, we want to check that that is unbounded. Now we're getting all these points here. There we go. So those are our points for our walls. For the walls from this spline, we want to go into transform points. We're going to need to rotate the walls 90 degrees. We're going to need a bounds modifier, which we'll set up in a bit. We're going to do this set steepness, set that to 1, so when we want to exclude those from other paths, we can. And then we're going to do this at attribute mesh. And instead of the floor mesh, we want to grab our wall mesh, which we haven't set up yet. And then we want this same static mesh spawner with the mesh by attribute. And we have an error here because we don't have a wall mesh yet. So to create our wall mesh, and I'm actually going to recreate the floor mesh as well because this one is way too large, I am going to go into modeling mode and we're just going to create a box. We're going to do 200 by 10 by 200. I'll do the floor first. That's much smaller. We accept that. That will be created inside our third person because we're still in our third person map generated, and then here is that. So what I would like to do is go into our PCG and just create a new folder in there called meshes, and then we'll take that generated, we'll copy it to meshes, and then we'll rename this SM floor. Same for the wall, we'll create another box. This one we want to be 20 wide, 200 deep, and 200 high. So let's do 200 wide and 20 deep. I don't like that 20, let's make it 10. And there is the wall. So under generated, we've got the wall. Copy that into meshes and rename that SM wall. We can delete these from the scene. Back up to our BP room. We can change our floor mesh to SM floor. And we can change our wall mesh, SM wall. Now, zoom in on that, and we can see we have our walls, and we see these are off all the way around, and we can fix that back in our transform points. We just set this offset to 100, and 100 might need to be negative. Nope, 100 is the correct direction. And now we have walls all the way around our room. Perfect. We can go into this wall static mesh and we can set a better texture. I'm going to import a couple of textures. I'm going to add a folder here to contain textures. And I have a couple of textures that I've downloaded from Polyhaven. If you're not familiar with this website, Polyhaven, you should check it out. A lot of excellent textures. You can also get textures from PixelBridge, but this is a good website to use. I'm going to download this wood cabinet long that I think will match well with the door model that I have and the look I'm going for. And then I'm going to get these stone tiles O2 and import those to the project. So I use the GLTF format. And then you just drag in the GLTF and it'll import those. It's really easy to set up these days. Now that those are imported, I'm going to go back over to the wall and just set that material and see how it looks. And that's pretty good. Take a look at it in the scene. Much more interesting. And then we'll do the floor as well. There we go. Nice. Realizing and looking at this with the textures on, it's a little more obvious that I made these walls too short. And if I pull Manny in here, we can see he's almost as tall as the wall. I'm going to go ahead and modify this wall, make it a little taller. We can use the modeling mode again to do that. So pull that in and then I'll go into modeling and then after you do that, if your texture looks stretched, depending on what you used, you can go down to the UV tab. You go project UVs, set this into box mode. So you can modify the size of the box. Right here you can see this is 10 by 200 by 287 as the size of the box. If I change this to like 200 here, it's going to shrink that box and then it's going to have more repetition in that wall. And you might be able to get a better look by changing this. I'm going to keep it the way it was though, but I wanted to mention that. To create our doors, we're going to do somewhat similar to what we did for the walls in that we're going to use a function first. And what I want to do is copy this get corners. So I'm going to go out here to my PCG folder where I have that stored in PCG functions. And I'm going to make a copy of get corners. And we're going to call this get centers because I'm going to put the doors in the centers on each wall. And then we're going to add some parameters to turn those on or off depending on which wall we actually want doors on. This is our new get centers. Instead of making a vector of plus x minus y, plus x plus y, etc., what we want is just a single value here. We're going to use plus x, we use minus y here, and then we'll have minus x here and plus y on the bottom. And so we just need to break the unwanted connections out here. So we have just plus y coming in here on the bottom. Here we're just going to have minus x. Here we're going to have just minus y. And we're going to need another one of these up here where we're just going to have plus x. And so these additions are the same. We're adding to the center and we're just moving out to the wall. So this will move out in the x direction to that wall, and this moves in the y direction to that wall, and these move to the opposite sides. And then we're going to add some branches over here. So each of these is going to go into a branch, and then we'll take this output to B, connect those into the merge. And the reason is because hidden in here is an output to B setting. So if this is true, it's going to go out to B, otherwise it's going to go out to A. So if we just don't use the A, we only use the B, this is essentially an on-off. So first, before we proceed, I want to fix this. There's an error right here. This line shouldn't be connected to the half extent. This should be connected to X. So let's just fix that. Then we're going to go to our BP room, and we're going to add in a parameter for each of the doors. So we're going to call this door north. And these are all going to be Booleans. And then we're going to go door east, south, and west. And make those all visible. Then back in our PCG get centers, we can get actor property. And when we get that property, we're going to want to get from parent instead of from self. And we'll get the door north, and we'll set that both as the property name, the output name, and then we'll also rename this node to door north so that way it's clear. And then we'll just duplicate this for the others. And now we want to move these up and hook these into the output to B. Make a little more room, and we can fit those right in the graph here. When we go out here to our main map, we want to go down here and turn on those directions. The next thing we want to do is we want to actually spawn in those doors at those locations. And I had initially set this up with the door mesh here, but we need this not to be a static mesh. The door needs to be an actor. I have a BP door actor set up, and I will include a video here for you to set up that door. A door that opens and closes, which you can add to your Unreal game. It's easy to create. Download a door model, GLB format, drag the door parts into your scene, select the door parts, actor, merge actors, merge, save, repeat for the frame. Delete from the scene, bring the merged objects back in, resize to the correct scale, go into the modeling mode, go to transform, edit pivot, set the pivot of the door frame to bottom, the pivot of the door to bottom, adjust its location to the hinge location, accept, bake transform, open the door frame, under collision, remove collision, then auto convex collision, click apply, save, create a new blueprint actor and open it. Add 2 static meshes, one for the door, one for the frame. Set those. Create a blueprint interface, function interact, door BP, class settings, add interface, interact interface. Interact under interfaces, add a timeline, door rotate, double click a new float track, rotate Z, length to 2, right click the line, add a key, add a second key, first key set 0, 0, second key 2, -90. Event graph, drag the door in, set relative rotation, break the new rotation, drag rotate Z to new rotation Z. Add a boolean is open, add a branch, hook true to play to start, false to reverse from end. Hook this up to not. On finished, set is open to not is open. Character blueprint, event tick, veer trace by channel. Get actor location, get actor forward vector. New variable, interact range, float 200. Actor location to start, connect the tick, multiply forward vector by interact range. Add to location to the end. Branch to return value, break the hit result. Tick the hit actor does implement interface, the interact interface. Connect to another branch, promote hit actor to a variable, interactable object. Set that on true. On false, set that to nothing. Connect that to both falses. Content browser, input actions, add new action, IA interact. In inputs, IMC default, add new mapping, IA interact, map to E. In your character, IA interact event, get interactable object, convert to validated get, call interact. Drag the door BP into your scene and test. Now you have a door that opens and closes, which you can add to your Unreal game. And we can use that door model here, but we need to spawn actor. And spawn actor doesn't let us pass in the actor like we can to static mesh spawner. I'm gonna look for a solution for that for a future episode. For now, we're just gonna set BP door right here. We'll get this working, and then I'm gonna look for options on the next episode, see if we can get some difference in the doors. We have a couple of problems here. One is that our doors are obviously merging with the walls and not cut into the walls. So we're going to have to create a wall section here that cuts out this door, but we're also going to have to exclude the door section from the walls. And then we have doors that are facing the wrong direction here. We can fix both of those issues. So let's go into our get centers first, and let's turn off north and south. It's north and south that are turned. North is here. South is here. So we want to do a transform points. And we want to rotate that 90 degrees. And then we should see those are facing the correct direction, which is good. Now we want to go to our room graph, and we want to exclude these door points from the wall points. So we want to add up here, we want to add a difference. And our source is the modified points here, and our difference is the door points. And that should exclude those out. But yeah, as we see, there's a big hole now. So we have to insert this door into a wall. So we put a whole wall section in here. I'll show you how to do that now. So we want to take our SM wall, and we want to make a copy of that. And we're going to call this one SM door wall. Bring our wall in, and then we want to bring our door frame in. And those have different angles, so we want to rotate the wall to match the door. And then we want to get our door lined up with our wall like we want it. It's about like that. Then we're going to go into our modeling mode. We're going to create a box that's the same size as our door. If I put this box in here, I can move it into position. And that's about the right height for my door, 205. Now I can reset this depth and width. That looks about right. What we want is this to fit within the frame, not go outside the frame, not inside the frame. So when this creates an opening, it's within this door frame inside the wall. And now click accept. And then if we go into model, we select the wall and then we select the box with shift and then click Boolean. We'll cut a hole in that wall and then we can click accept. Then we want to go to our generated. We have this Boolean here. We'll copy that back to our meshes. We'll rename that. Call that SM door wall. When we move this, we rotated it and we see our pivot here is in the center. We need to go down here to transform. We want to edit pivot. We want to click bottom, accept, and then we want to bake the transform and accept. Now we go to our BP door, add that static mesh. If that's not automatically selected for you, select your static mesh here and then move that into the right position for our door. Look around it, make sure it's right on both sides. There we have it. Now we have that wall added to our door. We can come here. It does not show yet. So we're going to force regen and it still doesn't show. All right, so I'm not sure why force regen did not regenerate this wall here, but I just changed the size of my room like this and it fixed it. So you might have to do that to get your room to regenerate with the wall. We can see that we still have a gap here. And the reason that's happening is because we're actually removing more wall than one section. We've only put in one section for the door, but we've removed more than one section here from our generations. So what we need to do is go into here and we need to take a look at this. So if we debug this bounds, all right, I just had to change this here to the correct selection. Sometimes PCG graphs are real finicky when debugging and it wasn't showing the points here. Now they're here. That's way too big. Let's reduce that to 1. Okay, now we can see our points here for our wall around the room here. And we can see right here, we're seeing both this extent and this bounds. It's unclear which is which. We want to see this as an extent. Okay, that's helping. And then this one, well, we also want to see this as an extent because what we want to see is what we're actually colliding between the two. The extent on the walls is really hard to see because it's actually a little tiny line and we need to change that. All right, so a couple things we need to change here. So this difference should actually be after we set the steepness. That'll help out. So let's move this. The steepness setting to 1, we want before the difference. That's why we were doing that. And then we want this bounds to be a set, and we want to set -100, -100, -20, and then 100, 120. So we can see that hopefully. Okay, yes, now we are seeing those points. They're too big. So I change this bounds to, all right, -100, -10, -20, 100, 10, 20. We can look at the size of this. Now it's super skinny. What we want is for this extent to cover the wall of the door correctly and these extents to cover the walls correctly. They are currently wide this way and skinny this way, so we need to flip that. So we need this to be -10 here, -100 here, 10 here, 100. This should give us the size of our wall approximately that way. Then this extends here. We also need to set the steepness. So let's do that. Now our steepness is 1. Before our steepness was 1/2. So we want that steepness to be 1. That gives us a sharp edge between this extent and these. We want our difference node to be binary. Now that removes those walls sharply. And then we want to set this extent. That extent I am setting with the full cell size. We want that to be the half cell size. So I pulled the wrong line. Cut that. This half of the cell right there is what we want. Yeah, there we go. All right. So now this extent here is the right size. So it's not lined up with our wall. So my BP door is off center. I'm not sure how that happened. That needs to be fixed. Going into BP door, if we look at this is center on the wall, but we can see the location is at 48, 45, which is not right. I'm going to copy that value. I'm going to say 0 here, and then I'm going to go to the frame, and I'm going to say negative 48, 45, and I'm going to do the same with the door. And now this should all be centered correctly. File and save. And now this did not refresh. So I'm going to make this refresh by resizing. And we're refreshed, but now we lost our debug points, which is super fun. There's our debug points. So now we're centered up correctly with our extent. We're still losing, so we're losing 2 wall sections, and we can see why that is. So this extent goes from here over to here, and the next extent goes from here to here. So we're overlapping with 2 wall sections. And the reason is because our room size is even. If we make this odd, now our door is in the center. And then if we shrink this bounds a little bit, so they don't touch, it's now solid. Because our true center was in the middle of 2 walls, and now our true center is 1 wall, so it works correct. But we want the rooms to be odd in size. So anytime they're even, we're gonna get that gap. So we want to make sure we always set those odd, and then those will be correct. So I am back after Unreal crashing and losing half the project and then rebuilding everything. So if you notice a few little differences from cuts in the video, I had to re-record a couple of segments, and I re-recorded them from this version, not the original version. So there might be some minor little differences, but everything is working in the end, except for one thing. I want to show you, if we go to our doors here, they actually don't open, and we need to change something so that they do. So we'll go into PCG Room to spawn actor. Right now, the blueprint actors are collapsed. We need them not to be merged so that they work interactively. And then we play this again. They should work correctly. And there we go. So I was just doing some tidying up and final testing, and I noticed a problem. If you bring in the BP Room right now, it will hang the editor, and I think that's happening because there's uninitialized variables. What we should do here is we should check this floor mesh to make sure it's valid. So let's add an is valid there, because we really shouldn't do these calculations if it's not. And then you should go through your wall mesh and set a default wall mesh, a default floor mesh, and also I think set a default room size. I just set 1 by 1, same for cell size. I set 10 by 10 by 1, and then room extend 10 by 10 by 1. All these should get recalculated when you load, but if they're empty, I think it's causing a division by 0 somewhere in the PCG graph, and rather than throw an error, it is just hanging the editor. So make those changes to make sure your editor doesn't hang on you, prevent some headache. Now that we have this working, we can bring in several copies of our room and make this level more interesting. I'm going to move the Z on these all down to 0 so it's a little easier to work with, and then just set these up with different sizes. Oh, another thing I'd like to do, so we don't have this issue, is let's check for that. In BP Room, let's add a little function here at the beginning of the construction script to check if our room size XY is odd. Let's add a new function, and we'll call that function is odd. And what we'll do is we'll take our room size out, we'll split that, and then we'll do a modulo with 2. On a mod 2, if we have an even number, it's going to return 0, and if it's odd, then it'll return 1. What we want to do is equal to 1, and then we'll do our branch. On false, we want to add 1 to our room size, and then we want to set that back to our room size again. So we'll just add 1 to the X and set that back. And then for the Y, we're going to do the same thing. So I'm going to just copy these nodes over, and we're going to run both the true and the false path to this second branch for the Y. So move this down to the Y, and then we want to copy this over and do this same add 1 and set on false. Make sure these are odd, and then running that out to the return node on both paths. and make sure we're setting Y here, and we should be set. We also want to make sure on these sets that we hook up the other value. So when we're setting Y here on the second one, we want to hook the original X up, and then over here, when we're setting X, we want to hook the original Y up. Otherwise, we're going to end up setting these to 0, and that'll obviously cause problems. So make sure you hook those up as well. To our construction script is odd. Probably give that a better name. Room size odd. And so now our room size should always be odd. So now you can see we can successfully lay out multiple rooms, and we can just drag in multiple copies, or we can copy a room multiple times and set different parameters on those rooms. In the next episode, we're going to look at creating hallways between the rooms and spawning in props to flush out the contents of the room, as well as looking at setting different room types so that we can have those rooms look more interesting than just empty rooms and be connected together. As this series continues, I'm going to show you how to spawn in rooms using PCG in a variety of different sizes, and then create automated ways to connect them together. And we'll come up with some different schemes of connecting those together, be they hallways like this dungeon layout here, which is all done in PCG, or with rooms butting against each other and connecting directly. So we'll have lots of different options. So make sure you like and subscribe so you can catch all that content. I'll see you in the next episode.